Hey Comets, welcome to another day of learning, and here we are on our last day of the week for our packet. I'm on this page right here, writing inequalities. Previous page we talked a little bit about graphing equalities, so this kind of goes along with that. Writing inequalities can be a little bit tricky. You have to really think through the meaning of what's being said. So let's dive right into it. Okay, the minimum age for voting in the United States is 18 years old. Let A represent a voter's age. Okay, so we know that we're going to have an A, and we're going to have the number 18. Okay, I'm thinking through why I knew that. All right, well, this is the two givens in the statement. The minimum age for voting in the United States is 18 years old, and A is a person's age. Okay. So let's talk about this. To make this statement true, what could A be? All right. What are possible things, numbers that A could be for this to be a true statement? All right. If I'm 18, am I old enough to vote? Okay. Notice it says the minimum age of voting in the United States is 18. Okay. I think so. So I know I need to put that line under it here. Okay. Because that tells me it could be equal to. Now, the question is, do I want it to go this way or this way? All right? So, what about 20? If I'm 20, am I old enough to vote? Yeah, of course I am. Okay? So if I'm 20, am I more or less than 18? Yeah, I am more. So in other words, I want A to be more or equal to 18. Okay, let's think of some other examples. What about if I was 5 years old? Can I vote? All right. If I put 5 right here, 5 is not greater than 18, meaning 5 is not a solution to this. Okay, 5 is not an age where you can vote. What about 50? If I'm 50, I'm greater than or equal to 18. I'm old enough to vote. Okay, so I think we've got this set up correctly. Okay, let's look at the next one. All right. B, a theater seats up to 275 people. Let P represent the number of people attending a performance in the theater. Okay, so let's see. We know the numbers involved is going to be 275, and P is the number of people in the theater. Okay, now it seats up to 275. Could it be 275 people? I think so. Okay, seats up to means it could include 275. So I'm going to put that or equal to sign there. Now it's between these two signs. Okay, so if I had 300 people, all right, would that be a true statement? Okay, well, according to this, up to 275 people, 300 is too many. Okay, so this number here needs to be less than or equal to 275. Okay, think about that again. If I have 200 people, will that work? Okay, well, yeah, it would, right? Because 200 people is less than 275. If I put 200 over here, that's less than 275. We're in good shape. Okay? C. I know I'm doing a lot of these, but you can kind of go, pause it and then see how you do, and then try it again without, and then check it with the video. The minimum hourly pay for working in Maryland is $8.75. Let X represent hourly pay for working. All right, $8.75. And then I have my letter X. Okay, so the minimum hourly pay working for Maryland is $875. So could I be paid $8.75? Yeah, I think so. So I'm going to put the line there. And then what about if I get paid more? Are we going to be okay with that? I think so. So if X is more than $8.75, say it's $12, is that okay? Yeah, I think that's okay. So we're going to go this way. All right? So any number that's more than $8.75 is okay. All right? And then finally, D. Yes, we're going through the whole thing here. The local fair can give up to 410 people attending. Okay? Again, can it be 410 people? Yes, it can. Okay, oops, I forgot. It should be A. Okay, can it be 410? Yeah, I think so. So we're going to put the or equal to sign there. All right, now what about 415? Does that work? No, that's more than 410. So we want a number that is less than 410 or equal to 410. Okay? All right, moving on. Stretch your thinking. No, actually, you know what? Let's do this. Let you guys have a closer look at what I came up with on those 4 problems. All right, now moving on. Stretch your thinking. Carol has $53.95 and she washes cars for $8 each. Carol wants to attend a musical that costs $145.75. That's not cheap. Write and solve an inequality to determine the minimum number of cars Carol must watch to be able to buy the ticket to the musical. Okay, well, this is a little bit crazy. All right, it involves some things that we haven't done before, but I think we can do it. All right, so we know that she has $53.95. Okay, and then every time she washes a car, she's going to get $8. All right, so let's say C represents the number of cars. Okay, now she needs to get $145.75. Move this over just a little bit. 53.95 plus 8C. Now, is she going to be okay if she gets $145.75? Yes, she is. All right, so it could be or equal to. Now, is she going to be okay if what she makes on this side is more than $145? Or is she going to say, oh, no, I can't have more than that? No, that's ridiculous. She would be okay if she got more. All right, so we're going to put the sign that way. Now, what do we do with that? Well, we need to figure out what C is. Okay, so we're going to take away the $53.95 that she already has away from her goal. So minus $53.95. Okay, and then we're going to see what that would be using our calculator. Let's see, 145.75 minus 53.95. So she still needs to earn $91.80. Okay? So basically, she needs to wash enough cars for getting $8 a piece to meet this goal. Okay? So, how many cars, how many $8 pieces of money, or, you know, how many times will she need to get $8 in order to get to the 91.80? Well, let's divide 91.80 by 8. Okay, so 91.80 is on our screen right now. I'm going to divide that by 8, and we're going to get 11.475 cars. So she needs to wash 11 cars, and then when she's 0.475 through that last car, she needs to stop and tell them to pay the remaining amount. Now, that makes no sense, right? So if she only does 11 cars, will she have enough money? No. So, but she better be good and wash that 12th car all the way, even though she doesn't need that money. Remember, she's okay if she gets paid more than the 91.80. All right. So I think we should say she needs to wash 12 cars or more. 12 or more cars. Okay. Let you look at my thinking a little bit more there. Okay. 12 cars or more. All right, now for the rest of this challenge question, let's see what else we got here. Number 2, determine if the given values are solutions to the inequalities. Explain your reasoning. Well, this goes back to our definition of what is a solution. It makes the statement true. Okay, so you need to ask yourself, if B equals 3 1/4, and I know it's scary, there are fractions, if B equals 3 1/4, the solution to the inequality. Oh, I got it. Sorry, it took me a while. 5 1/2. I know there's fractions, and I guess that's what I was thinking about, and it threw me off. Sure, Mr. Sturts. All right. Will this go into here and make this a true statement? Okay, the only way to find out is to try it, and we'll see. So 5 1/2, is that less than 3 1/4? See what I did there? I took 3 1/4 and put it in for B, all right? And I'm going to add that to 2 3/4. Okay, a little addition of fractions review here. So I'm going to add these two fractions, 1/4 and 3/4, and I get 1 whole. Okay, 1 whole plus 3, 5, or sorry, 3, 4, 5, and that other would be 6. Is that a true statement? Is 5 1/2 less than 6? Is that true? No, that's true. So is this a solution? We would say yes. It is a solution. It makes the statement true. Okay? All right, let's try one more. Is h equaling 12 a solution to the inequality 3.2h is greater than or equal to 38.1? So let's write h equals 12, and our inequality is 3.2h is greater than or equal to 38.1. All right. So again, what we need to do is substitute. I'm going to put 12 in for h. Remember, number next to a variable means multiply. So we're going to take 3.2, we're going to multiply that by 12, and we're going to see if this is a true statement. Okay, so 3.2 times 12, 3.2 times 12, whoops, 3.2 times 12 equals 38.4. Is that greater than or equal to 38.1? Well, it is, right? It's barely, but it is greater than. So is this a solution? We would say yes. Yes, this is a solution. Okay? Because it makes that statement true. All right? Okay, so the next two are just like that. Okay, give them a try. Okay? And thank you guys for watching. I appreciate it, and we'll see you next time. Bye.